In this video tutorial, we're going to be talking about the chop method. We'll be covering the following points here: what chop does and how it works, the concepts of a chopping unit and chop points, and also the rhythm-seek palette class's chop method and how we access the rhythm sequences in a chop palette. This technique is complex, we find, and it's difficult for new users to get a grasp. So let me first explain how the process works, and then we'll show you an example which should hopefully make everything clear. So first of all, what it does. Essentially, I came up with this idea when I was working on pieces that involved computer parts. So I was very often, like a lot of composers these days, working with loops. Not straightforward loops, but all the same with loops. And I found that as I always wanted to combine techniques in both the audio and the instrumental domain, that I was not really using a technique in the score domain or the instrumental domain that somehow correlated to looping, audio looping. So I came up with this idea of score-based looping. So what we do is we divide rhythmic content into fragments for further use. And what we usually use it in is a process called intraphrasal looping. This results in fragments which are assembled into sequences using Fibonacci transitions, as we've discussed elsewhere. So the source material is fragmented based on specified chopping units and chopping points. So what's a chopping unit? This has to be a duplet rhythm, and it has to be an even subdivision of the beat basis. It's the smallest unit that we're going to chop a beat of our material into. Our chop points then define the start and end points of segments within one beat based on the chopping unit as a multiplier. So within a unit of chopping points 16th note, a quarter note could be segmented into one group of 4/16ths, which is the whole quarter note, two groups of 3/16ths, three groups of 2/16ths, or four groups of 1/16th. This would be represented in the following list of chop points. So how about the process? What we're doing is applying the chopping pattern to each beat of the original material. We're going to create one new rhythm sequence from each fragment, and each new rhythm sequence contains only one bar with a corresponding time signature. We only actually create notes from attacked notes in the original, so any notes with attacks in a previous fragment become rests in the new fragment. This example shows you the rhythm sequence fragments that you get by chopping this material you can now see on your screen. There's a chop method for the classes of rhythm-seek bar, rhythm-seek, and rhythm-seek palette, but generally most users will only need to use the rhythm-seek palette method. This generates a new rhythm-seek palette object from the existing one, and the new rhythm-seek palette has the same top-level structure as the original, but with a further level of nesting, where each rhythm sequence of the original is replaced by a new rhythm sequence palette containing the chops of the original. So each nested rhythm-seek palette consists of rhythm sequences with fragment bars produced by the chop method. The extra level of nesting requires extra ID references to the rhythm sequences. New rhythm sequences automatically are assigned consecutive numbered IDs, so the new rhythm sequences are accessed by a combination of the original rhythm sequences ID and the new rhythm sequences ID, the chopped rhythm sequences ID. IDs in the rhythm-seek map must then be lists. So for instance, the list 1-1 would refer to the first new rhythm sequence from the original rhythm sequence with the ID 1. The list 1-2 would reference the second new rhythm sequence, the second chop, from the original rhythm sequence with ID 1. The reference 2-1 would reference the first new rhythm sequence from the original rhythm sequence with ID 2. And the reference seek 3 2 would reference the second new rhythm sequence from the original rhythm seek with ID seek 3, because remember, we can use symbols or strings as IDs for any of our rhythm sequences or sets. So this example shows you how we can make a piece using the chop method. The first thing you see is the original rhythm sequence palette, with rhythm sequences with IDs 1, 2, and 3. And then an immediate call to chop that palette based on chopping points, as you can see in this list here, and a chopping unit of a 16th note. Then you can see on our Make Slippery Chicken call that our rhythm sequence palette is not the original palette, but the chopped palette. So the rhythm sequence map refers to the chopped palette and therefore requires references in the form of lists. So it's no longer just a simple 1, 2, or 3 to refer to a rhythm sequence, but lists 1, 1, 1, 2, 1, 3, etc. So 1, 1 refers to the first chop of the first rhythm sequence. 1, 2 refers to the second chop of the first rhythm sequence, etc. And we output this to MIDI and scores in the form of CMN and Lillipond output, as you can see.